Are you looking to become a data analyst in Power BI and master the Microsoft Power BI tool? Welcome back to Excel Island, where we are trying to learn and master the data analytics tool, Microsoft Power BI, over the next 100 days. And today is day 35. We've been doing quite a lot of learning for the past 34 days. You can catch previous live stream, previous lessons on the channel. We've covered quite a lot in Power BI and all you need to know within the Power BI interface. So far so good. Today is day 35 and we're actually on a course called Intermediate Data Modeling in Power BI. We'll be completing the part of this course today, which is the last chapter in this course, and the next live stream, which will be day 36, we're actually doing a case study in HR analytics. You don't want to miss that. Also, you have access to all the data files, Power BI files, Excel files, CSV files. Do make sure to download those files and practice along with me. Without further ado, let's get back to learning and finish this part of the course, which is called Intermediate Data Modeling in Power BI. Welcome back to day 35. We're actually using the DataCamp platform so far, as you've known. If this is your first time here, and I'm actually subscribed to a 1-year subscription on the DataCamp platform. So if I click on the career track section, you could actually see what the whole career path looks like. And I actually started this journey with data analysis in SQL career track, where I went over SQL, the concept of SQL over a 100-day period. We've actually completed that and we started the data analyst in Power BI career track also. Definitely, after finishing this data analyst in Power BI career track, the next journey we want to start is the data analyst in Python career track. So you definitely want to subscribe to the channel right now, put on the notification bell so you'll be the first to know whenever I go live and drop a new content or start learning this data analyst with Python career track also. You can see this part here, the data analyst in Power BI career track. We're actually 45% throughout the career track, and the goal is 100% learning, which is the completion part of the course. So we started data analysis in SQL earlier, which we've actually completed, and I'm still practicing and honing my skills in that also. If I click on data analysis in Power BI, we could actually see what the career track looks like. While that is coming up also, do not forget you have access to all the data sets, Power BI files, exercise files we've been using so far for this whole journey. You can download those files under the YouTube description. I just quickly want to show you what this career track looks like. You can see we have 17 courses so far, estimated for 48 hours. And we've covered quite all of this. This was data modeling, where we started data modeling, beginner data modeling. Then we moved to intermediate data modeling, where we learned all about Snowflake, star schemas, and how to build a successful, probably successful data model. So we're actually on the last chapter here. So let's continue with the course. Without further ado. So you can see we've covered quite a lot from everyday date dimension, which is creating date table and relationship. We understand the concept behind granularity and hierarchies. That is how structured, or the granularity is how your data tables are structured. And we did some advanced data modeling. They are looking at what is called or identifying performance problems. So let's do that real quick so you can complete this part of the course.
Welcome back. In this last lesson, we'll discuss ways to identify and solve performance issues. Power BI has the ability to manage huge databases and is usually pretty fast, but sometimes your end user could be waiting minutes for the visuals to load. It's important to know the good practices that will help lighten the work carried out by the machine to make your reports as efficient as possible. The first step in handling user-reported slowness issues is identifying where the slowness presents. There are a few places where things can go wrong. You might see slowness when importing data or querying a database via direct query. Rendering the visuals could take longer than it should. Performance can also be impacted by the use of calculated versus computed columns. Lastly, inefficient relationships can cause slow performance. There are other performance issues, but we won't focus on those in this course. There are multiple things you can do to optimize data import. The biggest one is to remove unnecessary rows and columns. If you have data which you know will not be used, it's best to delete it. Choosing the correct data type is also important. Storing numeric data as numbers takes up less space than storing it as strings. Additionally, having to cast the data back to numeric later on can slow down performance. Grouping and summarizing data can also improve performance because it means less data stored on disk and less work to aggregate results. Throughout this course, we have used the import model to bring in data from CSV or Excel files. When working with databases, however, there is a second model, direct query. Import stores all of the data in Power BI, whereas direct query allows Power BI to query the remote data source when needed. When working with direct query, the most important thing to keep in mind is that you want the database to be as fast as possible. One piece of advice is to limit the number of queries running in parallel. One of the most common data sources for Power BI is a relational database management system. When using direct query there, be sure to write efficient SQL queries and use appropriate indexes. The goal is to obtain from the database exactly the data necessary to solve a problem, and no more. Calculated columns are written in DAX, whereas computed columns come from Power Query, written in the M language. Both allow you to build custom columns from data, but they can differ in terms of performance. In general, computed columns are only slightly faster than simple calculated columns. However, computed columns can be considerably faster than complicated DAX queries when working with large datasets. This is because computed columns are generated at import time, meaning that they get built a single time. By contrast, calculated columns are generated per visual at runtime. Earlier, we looked at a use case of bidirectional filtering, finding relevant slicer entries between dimensions. Power BI offers an alternative since this type of relationship can be inefficient. We can create something called filter measures to avoid bidirectional relationships. Let's look at an example. We have two dimensions feeding into the summary statistics fact, year and geography. We want to display only the year and geography values which have appropriate values in the fact table. The filter measure called slicer my fact table will do that. Let's see how this works. We want to return the number 1 if conditions are met such that we have data in the fact table for a given value in a slicer. To do this, we first create a simple DAX measure, which uses the isEmpty function to determine if there are any values in the fact table. We want to get only cases in which the fact table is not empty for a given filter, and then convert that to an integer using the int function. This will return 1 when we have at least one value, and 0 when there are no values. From there, we can add a visual filter to any dimensional slicer and show items only when the filter measure returns 1. There are a few more tips which can help optimize performance for displaying visuals. First, use restrictive filters to minimize the number of data points which appear on visuals. Furthermore, limit the number of visuals which you can see on a single page, as each of these visuals needs to load each time. Also, avoid slow custom visuals. Custom visual authors do the best they can to release high-quality code, but these visuals might not always be speedy. That's it. Make sure to keep these tips in mind if you're ever faced with slow reports. Time for practice.
That's quite a lot of tips and tricks to play around Power BI. Okay, let's see. We have performance tips in Power BI, data types and calculation. Okay, let's look at this challenge here. Optimizing performance. So Power BI has the ability to manage huge amounts of data, but still, sometimes you can find yourself waiting minutes for the visuals to load. At that point, it is important to think about how to speed things up. There are multiple areas to optimize performance in. So put the optimization technique in the right category. Okay, we have load data with data import as direct query, calculated versus computed columns, inefficient relationships, displaying visuals. So if you look at this, using computed column instead of calculated columns for complex calculation, using computed columns instead of calculated columns for complex calculation, that should be using computed columns instead of calculated columns for complex calculation. I'll go for calculated versus. This should be it. So now, so skipping only the relevant data from the data sets. Keeping only relevant data. You can use direct query for that from the data sets. Direct query, minimize the amount of data shown in visuals. That's displaying visuals. Writing efficient SQL queries. Or let's skip that or not direct query. Using filter made instead of bidirectional filter direction. Without inefficient relationship. Limiting number of visuals on report page. Also displaying visuals. Choosing the correct data types. Correct data types can affect your common correct data types. Looking for a correct data type. Where would this one fall? Using the correct data types. Just trying to guess where it's going to fall. That should be under calculated column. We are doing those in Power Query. Oh, I know I'm missing this. Calculated versus computed columns. Actually, correct data type can affect our visuals. No way. If you choose the wrong data type, it will affect the visual. What? Let me look at under here. Oh, I'm confused about this one. If you don't choose the correct data type while importing, will it be under importing? It's saying, well done, you have a good understanding of what performance issues can cause your visuals to be slow. Let's how to resolve some of these issues in Power BI. I'm curious about this choosing the correct data type. Is it before or after import? When you're loading your data with data import or direct query, of course, you should use correct data type. Okay. Okay. Sometimes those information can skip your mind, but that's interesting to know. You can always get 100%. Come on. I tried over there. So let's look at performance tips in Power BI. Okay, performance tips in Power BI.
Welcome back. In this final demo, we'll use the Performance Analyzer again and look at how bidirectional filtering can be avoided to improve performance. Recall that you created a GeoID column in a previous exercise. It was done by merging 3 separate columns into one using Power Query. Alternatively to merging, you could create a new column, let's say concat, and use a concatenate function to concatenate, for example, NAICS code and establishment age code. Notice that concatenate only allows 2 arguments. To concatenate 3 columns or more, you'll need to use concatenate again, nested in the first concatenate call. In this example, I concatenated NAICS code, establishment age code, and geographic area name, which looks like this in a table. In the View menu, you can open the Performance Analyzer. After starting the recording, refresh the visuals a couple of times to measure the duration in milliseconds it takes to create a report. You'll need this in the exercises, where you'll compare the performance of the concatenate function with merging columns in Power Query. A final action to improve performance in Power BI could be when you're working with lots of bidirectional cross-filters in the data model. In the example where you had a report with a slicer for year and establishment age code, you don't want users to select a year or code that isn't present in the connected fact table. We achieve this by adding a bidirectional cross-filter in the data model. However, adding more and more bidirectional cross-filters comes at a performance cost. An alternative for bidirectional cross-filtering is using DAX syntax. First, let's remove the existing bidirectional cross-filters. Create a new measure. Let's call it slicer filter, which will check whether the fact table, business establishments by age, is not empty. If so, this formula returns the integer value of true, which is 1, and 0 when it is false. You could then use this measure as a filter on the year slicer. As a result, the year slicer will only show values which exist in the fact table, and will in this case get rid of all the 1960s data points. Note that you cannot replace a measure as a filter on the whole page or all pages levels. So, to apply the slicer filter on the establishment age code slicer as well, the filter needs to be applied in the same way. Don't worry too much about the precise formula. You'll get the chance to practice this during the exercises. The end result is that this allows you to do the equivalent of cross-filtering without all the performance penalties and potential data issues related to bidirectional cross-filtering. Let's get to the final set of exercises and improve Power BI's performance.
Okay, let's give it a shot. Let's improve the Power BI performance. Let's see. Yeah, data types and calculations, calculated versus computed columns, an alternative to bidirectional filtering. Then we'll come to the end of this intermediate data modeling. Quite interesting. Okay, the context is data types and calculations. Choosing data types in Power BI and Power Query is easy, and there are benefits to choosing the right data type upfront. Let's compare the performance difference between summing numeric data and converting string data to numeric in DAX before summing. So open the Power BI file name. So I'll just go to the Power BI file and quickly connect back to my data sets. I'll just open data types. So while that is coming up, so we open Power Query and go to the business establishments table. Duplicate the number of employees column and rename it to number of employees text. Okay, is that up? This is up. We have a couple of tables here, which I still need to point to the data sets. Back from here, you can see I have to point to the data set establishment age. I go to the data source, point to data set settings, and browse for it on my system here. You call it business establishment age. This is right here. You can see we just walk through the data set. This NAICS code, NAICS rather. I go to the data source, the CSV file. Browse for it. Let's look for it. This is it right here. Click on OK, and we are back. How about the geography table? Go to data source real quick. Geography right here. We could just walk through the data steps. The last one is the business establishments. Okay, let's go for the business establishments. We have it differently. Is it a CSV document? Let's look for it. This is here. Business establishments. Definitely that one. Because we don't have any business establishment file there. Let's see if you are right. Ooh, this is the wrong data. Uh-oh. Business establishment. Let's see. So I think we selected the wrong table. Let's see. This is not fair. Let me see. Uh-oh, it's not going to work. Come on. Let's try it one more time. I just want to close the... Just close it and open it one more time. Say open Power Query. Go to the business establishments table. Duplicate the number of columns, number of employees column, and rename it to number of employees text. Oh, let's give it a shot one more time. So business establishments data, establishment age, geography. Okay, let me look for the data here. Let me look at the data table view of the business establishment. So it contains this table here. So I need to compare it. Probably if I have the correct business establishment by age, this is by age. I want to open the CSV file real quick. Uh-oh, wrong. It is wrong. So this is the wrong data set. Let me see. Oh, how come we have the wrong data sets here? Establishment survey, establishment age, manufacturing time. Okay, I think what I could do is there's a solution to it. So I could just steal the data from here. I could just go to copy table. I could copy the table just to save time. It has copied. Then I go open an Excel file. Open an empty Excel file and just paste it. You see? Next. Uh-oh. I didn't get the delimiter then. Back. Okay. Oh, the delimiter is what? This one is showing no delimiter. Tab. Semicolon no. Comma no. Space. Nope. Order. Nope. Tab. I go with delimiter as tab. Let's find the tracing. Okay. I think we are on track. Let me just take a peep. The first one is 2017 NAICS code, which is 2017 NAICS code. Did I choose there? It has headers. My data has headers, definitely. I'm trying to compare the data sets. Establishment age code, year, general, number of films, year, number of films, number of establishments, or general number of films. Time is I'm on track. So the next one is next, finish. Let's see that. Oh, we did that. Uh-oh. What was that? What is last part here? This row guide. Oh, this was the row guide. I can actually just delete that. Let me see the last part here. Oh, row guide is part of the data, so I can't delete that. ID. So that's how I just copy the data just to save time. Nice on there. So I can just go back to my transform tab here. If I go back to my Excel file, I'll just save this somewhere. I'll save. I could browse for more. Go to my DataCamp resources, Microsoft Power BI, dataset section. I could just name it as datasets. Nope, a CSV file. You see, I could name business establishment. Saved. Never mind. So let me just connect to it, the first one first. Let's see if that works. It's going to work though. You can see user. Okay, you can see the data set says business establishment by age big txt file. So it's actually a txt file from the beginning from DataCamp source, but that's another way to actually solve it. Let me point to the txt file first. Business establishment by age big. Let me see. Business establishment by age, this is a business establishment by age big. I actually have access to the data set earlier. I have no idea. Oh, it's still wrong. It's still scattering. Let me see. Promoted headers, change data type. Then it is going to give me an error. I need to go back to the data source here and point to my own data source that I just copied back. Hopefully that is going to work. This is it here. Let's see. Is it the same thing? Uh-oh. What's the challenge right now? That part of the challenge you face. Come on. There's a solution to this. Or just to save time, I'll just discard this method and use minimize and go with this with the Power BI file right here. I'll use the interface. After the data set, got a data set here. It's not giving me issue this time around. So I just use the exercise files right here to save time. I open the file 4.1 data types. Sometimes you face challenges like that, then you have to troubleshoot it. So it's coming up. So I'll just use the Power BI interface on the DataCamp platform to save time and effort. So if I continue reading the instruction say open Power Query and go to the business establishments table. Okay, duplicate the number of employees column and rename it to number of employees text. Okay, this one is taking time. It's up. Funny enough, we have access to same data sets. You can see same data set though, but sometimes you face challenges beyond your power. So while this is coming up, the instruction says open Power Query and go to business establishment table. This is it here. And it says duplicate the number of employees right here. Right click and duplicate column. So it's going to drop it here. So rename it to number of employees text. Let's rename the column. Rename column. Next says change the data type of number of employees text to text. So we change the data type of this column to text. Let's see right here. Create a new measure in business establishment. Name some employees text that covers the text to a numeric value and then sum the values. The DAX formula to do this is okay. Maybe DAX formula to do this, or I can just close and apply. We should create a new measure in business establishments. So you just go to it's applying changes. Apply changes. That I prefer using my own Power BI local machine. It's kind of faster and easier to use. But I couldn't point to the data source right there. You can see this is still loading. Okay, it's complete. So just right click on the business establishment and create a new measure. So we're going to call this new measure. It's going to be called some employee. Some employees text, which is going to be equal to this sum x function. Sum x going to be the business establishments, that is table, business establishments table. Then comma value. The expression is going to be a value function. Let me just move this away. Okay, we have the value formula there. Value. Then business establishments, number of employees. So business establishment. Oh, come on. That's why I'm trying to use my own Power BI interface, because this can just act up unannounced. Power BI needs to be more faster again. This is not fair. Let me see if I can find a solution to this within my maybe my other file that I've connected to, then I won't have this issue of using. Let me see. That is still coming up. Exercises. You can tell the challenge you can face while working. Okay, let me see. I think I could use, let me just try if I could use this file right here. I have a whole lot of data sets here. Okay, let's use this file. Hopefully we won't have any challenges. This is another file entirely, business establishments by age. Okay, let me open this file right here. Probably I need to be more faster now. When it is still coming up. Man, that's one of the challenges you just face while trying to work with all this. Okay, let's go to the Power Query editor quick. I'm just trying to troubleshoot my file from here. I'm going to the business establishment data. What I could also do if I go to the data source here, number of employees. If I go to the data source here, and I try to change it, I'm trying to see what the data source looks like. If I can find my way around, you can establishment plus age plus big text. So I definitely sure I have access to the data set right here. I have access to the data sets. Definitely. Business establishment by age plus big. I have access to it. So what I could do is just to save time, go to the Power Query editor and point to a new source file. This is a TXT file. And then this is it here. Open. Look at it here. Right here. Right here. Right here and right here. Then drop it in here. Solution solved. Oh, why did I think about that since? Oh, I just wasted a couple of time there. But not bad. Problem solved. Problem solved. I know there's always a solution. I could just get rid of this as it was. I couldn't connect back to it, to the data source. Okay, I think we are good to go. And I could just make use of this Power BI interview because this is definitely maybe hanging and give you problem solved. So let's quickly connect back to this establishment by age. Let's look for establishment by age right here. Okay, solved. NAICS code. right there. So you can see I have to go through a couple of troubleshooting to solve it out. Then the final one is the geography. The geography, which is this one right here. So let's go back to this business establishment and change following the instruction. Right on track. Change the data type, duplicate the column. If I go to number of employees, right click, then duplicate column. I could just change it to number of employees text. Close the bracket there, then change it to a text data type. Then definitely close and apply. Then we have to create a DAX function. So change data type to this text, then create a DAX function, some employees text. So while it is loading, done. You can see that way it is quite faster. New measure while working within Power BI interface. I think we have to call it some employees text. Is going to be equal to what's the function there? The DAX function, some X function, some X. The table is business establishments, comma. We're going to use the value function and point to the employee text. That is our code. Then we close the brackets, log that in. You can see our function is right there and live, working fine. The next instruction is the first table visual should include role guide and number of employees for business establishment. Create two table visuals. So to create two table visuals, drop in a table. Let's drop in another table. So our first table, which is this one, should contain role guide and number of employees from business. Okay, role guide, the number of employees from business. We have it there. You can see it's right here. Let me just close this tab here and definitely make this wider. Then the second one should contain, the second visual should role guide and number of employees text. So the same thing right here. This time around, role guide, number of employees text. This one right here. So we have both on our visual. This is not showing total. This is not actually showing total. This number of employees is not showing the total as this is showing. So definitely something is wrong there. We could notice that immediately. So open the performance analyzer and refresh the visual 2 or 3 times, focusing on the DAX query components. Okay, let's open the performance analyzer in the view tab. Performance analyzer and refresh the visuals 2 or 3 times, focusing on the DAX query components. Which version of the number of employees column is faster to process? Okay, let's start recording. Okay, refresh couple of times, refresh. So you could see that, oh, we didn't name our table. This first table is 192, 164, 170, 121. So it's the first table, the one with this one. Which version of the numeric employees column is faster to process? The numeric one is faster to process. No doubt about that. So you could see that from this recording here, table. So you get it now. That's quite interesting. We solved that. Yeah, super excited we were able to solve that, even though we faced a couple of challenges. So let's look at the calculated versus computed columns. Calculated versus computed column. In the previous chapter, you learned how to create a new composite key. Okay, let's leave the context. Let's follow the instruction. Open the Power BI file name custom column from the exercise folder on the desktop. So we could just continue using this file. I don't open a new file. Okay, summary statistic manufacturing big to summary statistic completed column. Let me see if you still have access to those. I could just stop the recording and close the performance analyzer tab. Let me see whether we still have access to this Power Query file here. It says rename the summary statistics for manufacturing table to summary statistic completed column. We don't have summary statistics here. I definitely need to point to the data set one more time to solve that. Let me see. Okay, let's solve this challenge first. I think let's solve this little challenge, this last one, because I have to get done right now and be somewhere. Make a duplicate of the previous table and rename it as summary statistic calculated column. The instruction is kind of long, pretty long, which I have to come and perform and finalize it later before I move to the next course. Definitely we have to stop this live stream here today because I need to excuse myself right now. It's quite important. But you can see that we could actually solve our challenge no matter what we are facing with the challenge right here. Okay, so I'll be stopping here in this live stream. But on the next live stream, we are going to complete this part of the course, which is this intermediate data modeling, and start our new course, which is the HR analytics that I want to start the case study. We're starting a new case study on the next live stream, which is tomorrow, day 36. So I need to excuse myself right now. I need to attend to something very, very important. Time is not on my side again. All right, so thanks for staying to the end of the live stream. So if you found value in this live streaming section and learn Power BI with me, do make sure to support the channel by giving this video a thumbs up, hit that subscribe button so you can put on the notification bell so you'll be the first to know whenever I go live or drop a new content on the channel. As we go on the channel, I hope to see you to become a good data analyst just like me, and I'll see you on the next live.